can you also take the next concept which she is going to
Which
do this?
concepts?
The I think in the Nyquist plot and PID and the
Okay, look,
Bode.
uh, these are two independent sessions. Okay,
Yeah.
so we call them as doubt clearing session instead of I again revisit the content and teach some questions. So it is better you ask your questions.
Okay.
I think that would be the best way. Again, if I am teaching, I'll be teaching something else which may not be useful at these last hours just before quiz two. So instead, you ask your doubts, so I can explain you that.
Sir, forming of equation from Bode plot.
Forming of
There is a
equations.
from Bode plot.
What do you mean by forming of equations?
There is a question in PYQ.
Okay, you were saying given body plot, how to plot the uh, transform,
Equation.
how to write the equation
Yes,
transfer
yes,
function.
yes, sir.
Okay, have you tried any question? Can you show me? If you have tried any question, you can show me.
Sir, there is a question in PYQ. Uh, that is
Can
May
you post
25.
it? Can you post it? That would be more useful. So you can send me an email. That would be better.
Okay, 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 sir.
Yeah, yeah.
So in the chat box, I have pasted the question.
I think it chat box also fine. Email takes time, so chat box also works fine.
Sir, in the graded assignment, there is one question. We have given the D of S statistic equation, and we have
Just a
to
minute.
find.
Just a minute. Let's go one by one.
Sir, I have sent to in your mail.
Okay, I'm checking. Okay, given a stable negative feedback for the open transaction from space. So it's the type of a system. I think this seems to be easiest question. So I'll do one thing. Let me take a typical one so that you'll understand much better. Uh,
Okay, sir. Okay.
yeah. Okay. So can you see my screen? No. Okay. Yeah. Can I see my screen?
Yes, sir. Visible.
Yeah. Yeah. Just a minute. Okay. So the given Bode plot is something like this. So this is dB and this is omega. Let's say this is uh, zero somewhere, one, two, four, eight. I'll take this a bit later. Eight, so 24, 36. Hope you can see this image. Okay. So I have this one starts at 2, then zero, then goes like this, then till 24, then 36, then something like this. Okay, so let me go again. This one, this one. This was goes like this. Okay, and this is 8 to 24, 36. Yeah, now can you see this? So this is minus 20, 0, plus 20, 0, minus 20. This is minus 40. So okay, so this is the Bode plot given. Can you able to see this, everyone?
Yes, sir.
Yeah. So this is the general question. Okay. So here the question is the determine the transfer function. Okay, from the Bode plot. Okay. So now here you could see first we need to write the first I'm writing directly. So let me take this one out. So direct form of the transfer function. Okay, so based on uh, based on the slopes. Okay, now can you tell me here, based upon the slopes we will write. Okay, uh, tell me here, what is the slope change from here to here?
minus 20 to 0.
Plus 20. If you add plus 20 to this minus 20, it will become 0. Yes or no? So that's why it is slope change is plus 20. Am I correct? Here from this line to this line, what is the slope change? That is another plus 20.
Yes, sir.
Am I correct? From here to here, what is the slope change?
Then it will
Minus
be
20. Because if you add minus 20 to this plus 20, it will become 0. So similarly, what is here? Minus 20. Am I correct? Yes or no? Okay. Similarly, what is here? Minus 20. Am I correct? If you add minus 20 to minus 20, it will become minus 40. Am I correct? Yes or
Yes, sir.
no?
Yes, sir.
Yeah. So now always we look for the slope changes. Okay. Now let us write down specifically what are these things. Okay. So here you already know about the Bode plot. Okay. When you will have positive slopes, when you have negative slopes, when you have zero slopes. Correct? So based upon these values. Am I correct? Okay. So now if you see here, based upon the slope change, we can write. Here, what does this one indicates? What does this one indicates? Okay, let us say on x-axis we have y-axis some constant, sorry, x-axis 1, y-axis is some constant y. Can you agree for this? Y is some unknown. Okay, so now the velocity is the frequency is almost 0. Here we could have one pole because the slope is starting with minus 20. Yes or no?
Yes.
Slope is minus 20 means it relates to the pole. Correct?
Yes, sir. It's
And we are
already have.
talking, and we are talking about the almost zero slope. So that means that we have one pole at the origin. Will you agree?
Yes, sir. Dipole.
Yes. So now, what about here? What about here?
0, sir.
So here, this is what?
Zeros.
0. Okay. So what would I say? 1, 0 at omega c equal to what? 2.
2.
Will you agree? Correct. Similarly, what about this one here? Is it 0
Another
or
0.
again
Another 0.
because we are adding another plus 20? Correct. So
Mm-hmm.
another 0 at what? Omega c equal to 4. Will you agree?
Mm-hmm.
Okay. So similarly, what about this one?
Pole.
So this you are adding minus 20. Okay. So one pole at omega c equal to 8. Am I correct? Okay. So what about this one? Again, you are adding minus 20. So it means that one pole at omega c equal to 24. Will you agree?
Yes, sir.
Yes. What about this one?
Another pole.
Again, you are adding one more pole. So omega c equal to 36. Am I correct? So is these things clear? Any doubt? Because that is our they gives us the transfer function equation.
Sir, how will be the last one pole?
The last one is always look for the slope change. Okay. So if the slope change is positive, 0 will be added. If slope change is negative, pole will be added.
Okay,
So
okay.
yeah, so that's how we see how the slope is changing, positive 20 or negative 20. Okay. Any queries on these green marked
Sir,
ones? Yeah.
sir, starting pole, that is, or you wrote origin, uh,
Yes.
but
Yes.
value is that one. Uh, it will be on
One is
one
already
or
there in
less.
the x-axis. One is already there in the x-axis. It is low frequency, and I'm taking the other value as y. Okay.
Okay.
That y still I need to find. Okay. That y still I need to find. Then the slope change is coming minus 20. So that's why I took that is as pole. But that is since the one is at almost close to 0, I took that is as origin.
Okay, sir.
One pole at origin.
Okay.
All the remaining things are omega c values, but you have to check the pole, whether the pole is added as 0 is added. Okay. Now I am writing like this. Okay. So the transfer function based upon what are the poles we have and their locations. Okay. So I'll write this one as some constant I require, because that will be for open loop system. Okay. So now look at the zeros and write them. Where we have zeros, we have 1 0 here, another 0 here. What is first 0? Omega c is
Yes.
equal to
Yes,
2.
plus 2.
So that's why I write s by 2 plus 1. Is this clear? What is it basically? Tau s plus 1, correct? That is nothing but what? S by omega c. Am I correct? Plus 1. Am I correct? That's what we need to add. S by omega c plus 1. T means what? 1 by omega c. Okay. What is another 0? S by 4 plus 1. Is this clear? Only two zeros. This 0 and this 0. Clear? Okay. Any doubt? What are the poles? One pole at 0. So another pole at omega c is equal to 8. Another pole at this location. Another pole at this location. Is this clear? Is this clear?
Yes, sir.
Yeah. Now you see carefully. Okay. So I'm writing this something as this slope, initial slope, minus 20 as like this. What is this one is? This one is 80, 0. Am I correct? 8, 0. Yes or no?
Yes, sir.
Yeah. And this is 1, y. This is 8, 0. And in between we have this straight line. That straight line having a slope of minus 20. Is that correct? Yeah. So now I am writing like y2 minus y1 by, okay, x2 minus x1. X2 is log 1, x1 is log 8. Is this clear?
Sorry, sir.
Yes.
But I didn't get that point. The line extending from 1 comma y reaches to 8 comma
See,
0.
this is 1 comma y, correct?
Yes.
This is 8 comma 0, correct?
Mm-hmm.
And from here to here, you have a line. See that orange line? That orange line is continuation of that blue line. That is given in the problem itself.
Okay. Mm.
Okay, so this line.
Okay.
So that blue line is sort of root locus, but the orange line is just imaginary line, but that is continuation, correct?
So that continuation is already given in question.
Yes, yes, yes.
Okay. Okay.
Like the dotted lines and that thick orange line is already given in the question. Okay. So now this is log omega. Am I correct? Logarithmic scale. So that's why it is log 1 by 8. It means that instead of 8 minus 1, we say log 1 minus log 8. Okay. So from this, we can calculate y. Can you calculate y? We'll get that is as 18.
Sir, I can't
You can use your
understand the
calculator.
formula.
Yes.
It is log 1 by 8.
This is yeah. This is log scale. It is not omega. Log omega. Okay. That is log omega. So it means that all these values are log values. Okay. So in all Bode plots, the slope is nothing but x-axis is logarithmic. Okay. Y values are dB values. Okay. Y in dB, 18 dB. X-axis is logarithmic. Okay. That you must understand. Okay. Because x-axis is not simple y. Instead, it is logarithmic scale. Okay. So you get now y as 18. Once you have y 18, what you do is now, so how can I write that 18? I got this y
Sir,
as 18 now.
it is not natural log, no? It's log base 10.
It is ln log. I mean, sorry, it is log only, just log, not natural log.
Yes, sir.
Okay. Yeah. So now our job is to find what is this k value. Okay. That's it. So for that, we have to find this y. Once we have this y, okay, so now the y can be written as, okay, so 20 log k, okay, plus slope, okay, log omega. 20 log k plus slope log omega. So what does this mean? Can anyone tell me? Can anyone tell me what does this mean?
Y is equal to mx plus c.
Yes, it is that form. Okay. So what is this k represents now? K represents what? It's the intersection. Am I correct?
Yeah.
Yeah, it's the intersection with y-axis. Correct? It's the intersection with y-axis. So that's the meaning. Y-axis at y omega is equal to 1. Okay. So now you can substitute the values. 18 equal to 20 log k. Okay. So plus what is the slope? Initial slope is minus 20. Okay. Multiplied log 1. Okay. So you can write this one as log 1 is 0. Log 1 is 0. Okay. Hence, so log k equal to 18 by 20. Okay. Log k is 18 by 20. So this means k equal to what? 10 power. Am I correct? 18 by 20. 18 by 20. So this means k equal to what? 7.94. K equal to 7.94. Okay. So finally, my T of S is 7.94. Okay. Or we can write it as 8. I'll write that one as 8 multiplied. So S by 2 plus 1, S by 4 plus 1 divided by, so S multiplied S by 8 plus 1, S by 24 plus 1, so S by 36 plus 1. So same equation, whatever we have here, same thing. Okay, so this is my final equation. Okay, so that is how you can find, given the Bode plot, okay, given the Bode plot, you can find the transfer function.
Sir, if
Sir, that line
Yes.
we have taken for the slope means is that line is given in the question?
This is already given. That's why I said clearly. This line is already given.
Okay.
Yes.
And sir, from where that means this is the formula of the transfer function for the body plot.
This is not the formula.
Mm,
This is the
means
format I
after
wrote.
calculating all the poles and zeros.
Yes, yes. This is how we need to write, starting from each one. Starting
Okay,
from
okay.
each one. Give me a minute. Sorry. Yes, tell me. So in general, what we do is, given Bode plot, we have to see that setting. First, we need to identify these slope changes. Okay, the slope changes are caused by uh, adding pole or zero. Hence, we can easily identify. So the this format. Okay. Any doubt? Any doubts or queries?
No, sir.
Yeah. So this is the general problem. So you can solve any problem by following this procedure. So it is majorly on the based on the slope changes. Okay. Yeah. So any other questions?
sir, question regarding PM and GM.
The gain margin and phase margin
Yes. Same.
means from Bode plot to phase margin and from Nyquist to gain margin.
Hello. Can you see the screen?
Yes, sir.
Yeah. So your doubt is what is this phase margin and gain margin? So this is the Bode plot. In Bode plot, what we do is we take this open loop transfer function. For that open loop transfer function, in place of S, we substitute S is equal to J omega. So we get this open loop transfer function. To the open loop transfer function, we plot magnitude plot, which is nothing but 20 log of that open loop transfer function, and phase plot, which is nothing but the angle of that open loop transfer function. I hope this is clear. Is there any doubt, anyone?
Sir, can you just explain it a little?
How to plot this?
Yes, sir.
Okay, okay. I think I have. Yeah. Okay, you can see this example. Okay, so we have this transfer function. Okay, KSSY by 1 plus 0.2s 1 plus 0.02. Okay, so this transfer function is in this form. Am I correct? Okay, so first substitute S is equal to J omega. Okay, you get this one. Okay, for instance, take K is equal to 1. Okay, this is your transfer function where wherever there is S, you substitute S is equal to J omega. Is this step clear? First step?
Yes, sir.
Yes. Okay. Then for this, we are going to draw the Bode plot. Okay. So first what you do is, so you identify the poles and zeros. Number of poles and zeros what we have. So the zeros are 1, 0. Okay. How many zeros we have? Let's say M is equal to 2. Correct. And the number of poles is also 2. Correct. Okay. So here, even though we have 2 zeros, okay, but both the zeros are existing at S is equal to 0. Am I correct? So S is equal to 0, both the zeros. Okay, in general, this is the procedure we follow. Okay, so first we take those terms. This is the, this term represents both the zeros. This term represents this one. The other term represents this one. Okay, we call these are the terms. Is this step clear? Okay, we form this small table from this transfer function. Is this clear? These two parts?
Yes, sir.
Any? Yeah. So then what we do is we'll find something called corner frequencies. Okay. Corner frequency means, okay, first term we don't do anything because we are not interested in that. Okay. The second term, corner frequency is nothing but inverse of the time constant.
Sir,
Okay. Yeah.
in
Yes.
change of slope, I think.
No. Listen. I haven't gone to that level yet. We are going step by step. Okay. So we are finding the corner frequency. Corner frequency is nothing but inverse of this time constant. You can see here 1 by time constant, 1 by this one. These are the corner frequencies. Is this clear? Any doubt? Okay. Now we are finding the slope. Okay. This is also over. Now we are going to find the slope of each corner, slope at each corner frequency. Okay. Here, what are these two things exactly?
Zeros.
Zeros. Okay, always 0 will give you plus 20 dB per decade. Pole will give you minus 20 per decade. Here we have two zeros. That's why the slope is plus 40 dB per decade. That much slope it will inject into the system. Correct? Then we have one pole, so minus 20. We have another pole, minus 20. Is this step clear? This one. So in this column, we have exactly found which pole, how much slope it is generating. Is this step clear? Okay.
Yes, sir.
Yeah. Then this is important step. change in the slope. Okay, after adding that particular fold, okay, what kind of change is coming, right? This is how we will find. First, what we do is, let me remove this. You should understand clearly. So first what we do is, so this is 2 zeros. Before that, what is it? We don't know. Okay, what we have. So that's why we don't want to calculate the slope change at that particular first point. Then at second point, we are adding a slope of -20, okay, to the existing. Existing is +40, okay. So we are adding a slope of -20. What is the slope now? +20. Is it clear? Is this clear? Next, this is the existing slope. We are adding a slope. Then the resultant is 0. Is this step clear? Any queries? Because these things we will use while drawing the Bode plot. Any queries here? Of course, I'll give this notes also. Any query here? I'm hoping that there is no query, doubt here. Yeah. Okay. Then what we do is we will start calculating the slopes.
Sir,
Okay. Yeah.
in the previous one, what is that m is equal to 2 and is equal to 2?
Sorry.
On the right corner, top.
Is these two things clear? M is equal to 2 in the sense we have 2 zeros, 2 poles.
Okay.
Is this step clear? Any doubts? Slope change?
No.
Okay. Yeah. Then what we do is at every corner point we will start checking. Okay. So now we will start with the first one. Okay. So here you could see what is the omega C1 we have. Omega C1 is 5. Okay. What is the omega C2? We have 50. Okay. What we will do is we will try to take a frequency which is very far, which is very below this 5. That we call it is as a this one. Very less than the omega C1, which is nothing but 5. Okay. Then we take it 5. Then we take it 10. Then we take a frequency which is far greater than omega C2. That is, omega C2 is how much? 50. Is that clear? What is basically Bode plot is when you vary your frequency from lower value to the higher value, correct? So, but the given problem, what are the values we have? We have value 5, we have value 50 only. Okay. So we wanted to check one value very almost close to 0. That is, we call that is as omega L. Also, we wanted to check very highest value greater than 50. That is almost equal to infinity. That we call as omega H. For all these 4 frequencies, we wanted to calculate and draw the Bode plot. Am I correct? Yeah. Now here you could see. So first one is we have to choose this value. That value is omega L is, we are choosing like this. So omega C1 is 5. We are choosing omega L is 0.5. Is this clear? Okay. Then we have to calculate this, the y-axis value. Y-axis is basically what? 20 log j omega. This one. Am I correct? You can see here. This is y-axis. We have 20 log open loop transfer function. Okay. In this case, this is that term. Okay. So now we are calculating this. At what is j of j omega? At omega L is equal to 0.5. That value is j omega square. Am I correct? because the omega c is almost 0. Am I correct? So the modulus will be smart omega square. You are substituting 0.5, you are getting minus 12 dB. Is this clear? Any doubt? This part.
Sir, why that square came there?
This one. That's come j
Yeah.
omega. This g of j omega is j omega square when omega is equal to 0. This term.
Okay, sir.
Yeah. Is that clear? Next. When we reach omega c1 is equal to 5. When we reach omega c1 is equal to 5, we almost reach this end of this j omega square. So that's why we are taking the same expression. Instead of 0.5, now we substitute 5. This is the value. Is this step clear? Is this step clear?
Yes, sir.
Yeah. So when omega L is equal to 0.5, the magnitude on y-axis is minus 12 dB. You should remember that. When omega C1 is equal to 5, the magnitude is 28 dB. These two values we needed. Okay. Then next. Okay.
Sir,
This is as it is. Yeah.
we can take the value omega L equal to 0.1.
Yeah, we
Or
can take. Not an issue. We can take.
okay. Okay.
Usually what we do is we take I think 1/10 of its value, 1/10 of omega c1. That's what we do practically.
Okay.
That's why we get 0.5. And at omega c we take I think 10 times omega c2. Omega h. This is omega L. This is omega h. Let me check that value there. Yeah, you see, this is 50. How much you are taking? We are taking omega h is 2 times. Yeah, omega
Yes,
c2. Yeah, this is practical. Okay. But still you can take more values also. I think this is not the correct. Okay. Yeah. The next omega c1 is equal to 5. This we have already calculated at 5. Okay. Now this is the starting. Next step is omega c2 is equal to 50. Am I correct?
yes,
Next
sir.
one. Then what you are doing is something like this. Can anyone tell me what is this? Can anyone tell me what is that?
Straight line equation.
Yeah, you can use this one. This is the straight line equation. Okay. So this is the omega c1. This is omega c2. And here you have something. Is this clear? This is A at omega c1. This is A at omega c2. Is this clear? That is nothing but y is equal to mx plus c. You got it? This is the m. Sorry. Slope from omega c to omega. Yeah, correct. This is the omega m. Okay. This is the c value. Okay. This is slope and this is x value. This difference. Is this clear? So that means whenever omega c is equal to omega c2, the value is what? 48 dB. Is this clear? Any doubt? Next. Then finally, after omega c2, we are going to choose omega h, which is equivalent to 100. We are choosing that is as practically 2 times c omega c2. So again, we are doing the same thing. This is omega c2. This is omega h. Again, we are doing the same thing. So omega c2 value plus the slope plus multiplied by x. So we are getting 48 dB. So this is how your sequence goes. Omega L, omega C1, omega C2, omega H. Is this step clear? Okay, this should be clear. Okay, now we will draw. We will draw the, not this one. We can draw this plot. Okay, of course, we can also see. So, what is our transfer function we have? So, the transfer function g of j omega is j omega whole square plus 0.22s plus 1. I'm sorry, 0.22 omega s omega 1 plus 0.02 omega plus 1. Correct? Oh, already given here. I'm sorry. This is already given. Okay. So that can be written as this one is related to 180. Am I correct? What is the angle for j omega? That is written as what? J omega written as what? 0 plus j omega. Am I correct? Correct. So this is like what? A plus jb. What is theta? Tan
0 degree.
inverse. Tan inverse b by a. Here what is it? Tan inverse omega by 0. That is what? Infinity. Tan inverse infinity is what? 90 degrees. Am I
Yes, sir.
correct?
Yes, sir.
So
19
that's
to
why,
2.
yeah, 90 into 2. J omega multiplied j omega. Okay. Similarly, when these things goes up, they'll become negative. Okay. This is the phase angle. Now what we do is, what is our starting and ending? Omega L is 0.5 and omega H is 100. You take some different values in between. Okay. Calculate these terms. Finally, calculate the pi. Is this clear? Okay. Now draw the border plot. Okay. Border plot is drawing the magnitude plot and phase plot. Okay. How do you draw the magnitude plot?
Sir, in
Yes.
previous question, in previous slide, sorry,
Yes.
the above equation 5, is it
Uh,
equated to minus 180 degree?
this one.
5 one, the top one.
This one only you're saying no.
Yes, yes, yes.
The
Is
question
it
is
entire equation is equated to minus 180 degree or not?
no. This is for numerator. Okay. These
Uh,
are for denominators. When they go up, they'll become negatives.
okay, so we are putting the values in
Uh,
this method 0.51510.
I don't understand.
I mean, we are putting value one by one. Omega is equal
Correct,
to zero
correct,
point 0.5.
correct, correct.
Okay, this.
Yeah, we substitute these omegas into this equation and we are calculating phi. That's it.
Okay, thank you.
Okay, these omegas, they came from the magnitude plots limits. This is omega L, this is omega H, this is somewhere omega C1, somewhere omega C2, this one. Correct? We take different values and calculate all this. Okay. Then Bode plot is nothing but drawing the magnitude plot and phase plot. Okay. Magnitude plot, what we do is, first you observe this, you take these values, omega L, omega C1, omega C2, omega H. Is this clear? Okay. Now you see at omega L 0.5, what is the value we got? Minus 12. Let me show you that. This is minus 12. This is clear? Then omega
Yes, yes.
C15, we got 28 dB. This is the 28 dB. So you calculate these 2 points with this straight line, red line. At this one, omega C1. Next, omega C1 is 28 dB. Omega C2 is at 50 is 48 dB. So this is 28 dB. This is 48 dB. Okay. Then omega H. Omega H here. Yeah, that is again 48 dB. At omega H is equal to 100. Okay, this one. So from all the values, 48 dB. Is this step clear? This is your Bode plot, magnitude plot. Okay, so phase plot also we draw the same thing. We take omega L, omega C1, omega C2 and plot these values. Take this phi on the y-axis. Okay, 174, 168, 130, 106, 50, 30. So 174, 130, 50, 30. So this is your magnitude plot. Is this step clear? I think this is the simplest way to draw the Bode plot. Am I correct? Any doubts or queries? We have another example also. You can solve this. I'll give you this handwritten notes. Okay. Is there any doubt in this example? Anyone? Any doubt?
No, sir.
Yeah.
So
Now, yeah.
PM and GM over here,
Yes,
and
yes. I understand.
critical one.
Yeah, if you don't have
little-
any doubts here, then we'll go to that topic. Okay, now I'm assuming that you know how to draw the both magnitude plot and phase plot of the Bode plot. Okay. Now I'll explain clearly what is this gain margin and phase margin, how to calculate basically from these plots. Okay. Now you could see this right. I call this is as the right side. I call this is as, sorry, this is left and this is right. Okay. So in right side, you could see these both are magnitude plot as well as phase plot. Okay. So I'm only considering right side, left side. Okay. First, we'll talk about the gain margin. Okay. First, we'll talk about the gain margin. So gain margin, what we do is, okay, first you go to this phase plot. First, go to this phase plot. Okay. This is your phase plot. Am I correct? Am I correct? Any doubts here?
No, sir.
No. So in this, now all these are angles. Okay. Draw this horizontal line at minus 180 degrees. Can you do that? At minus 180, draw that horizontal line, this line. Okay. Once you draw that, that will cut the axis here. That will cut the plot here. Is that clear? Okay. Step one is you draw this line. Okay, minus 180, that will cut that axis here. Now draw this vertical line. Okay, then you'll have this point. Is this step clear? Is this step clear? We are interested in finding the gain margin. In that gain margin, the first step is, okay, see this phase plot, draw this minus horizontal line at minus 180. Okay, and wherever it is intersecting with the phase plot, draw this vertical line. Then you'll have this omega PC comma minus 180 coordinate. That omega PC we call that is as a phase crossover frequency. Is this point clear, everyone?
Yes, sir.
Yes. Once you get that, okay, phase crossover frequency, now go to this image. Okay. In this image, now, can you see this 0 dB line? First draw that 0 dB line. Okay. So once you draw that 0 dB line, okay, and you are extending this omega PC line till this. Right? Previously you have drawn this omega PC line, correct? Okay. Now it is going to intersect with here. Am I correct? Yes or no? It is intersecting that one at minus 10. Am I correct?
Yes, sir.
So that means how distance it is from this 0 dB line? This minus 10 line,
20.
that is 10. Am I correct? That is 0 dB line is 10 dB above this intersecting point. Am I correct?
Yes, sir. Yes.
Okay. How you are getting that 10 dB point? Because we have identified this phase crossover frequency. Correct? How you get this phase crossover frequency? Because you have drawn this minus 180 horizontal line. Okay. This minus 10 dB line is called your gain margin. Is this step clear?
Yes, sir.
Here the 10 dB line, okay, is it below the 0 dB line or above the 0 dB line? If it is below, it will be 10 dB gain margin. If it is above, it will be minus 10 dB. Is this point clear?
Yes, sir.
Any queries?
So far,
So basically, who is giving your gain margin? The gain margin is basically given by
crossover
this,
frequency.
yes, crossover frequency and this minus 180 degree line. Okay, that is called as the gain margin. So once you draw your, so this is called as the gain margin. Similarly, now check this one. We do the same analysis for the phase margin. Phase margin, now what you do is you start with the magnitude plot, draw this line now, 0 dB line, horizontal line. Okay, now it is going to intersect at some point. Okay, draw this vertical line now. Okay, wherever it is intersecting, this is called as the omega GC and y-axis is 0. That we call that is as a gain crossover frequency. Okay, similarly go down, extend this till the end. Now see, this is your minus 180, correct? This is your minus 180 line, this point. Okay, now again see, okay, so this is where your this omega GC line is intersecting. It is not intersecting at minus 180. Am I correct?
Yes, sir.
Yes. So it is intersecting by this much width. Okay, that is nothing but the P plus 180. What is the P value? Minus 20. It is minus 180. Is this clear? Sorry, minus 20. Is this clear?
Yes, sir.
Yeah. So now this is called as the phase margin. The phase margin is we have calculated by starting the drawing the 0 dB line and then gain crossover frequency, extending that gave us this line. Okay. Then we are checking with the minus 180 degree line. Is this step clear? So that is how we calculate the gain crossover frequency, then phase margin. So depends upon this omega GC is intersecting with the phase curve. Okay, above or below the minus 180, we say that is as positive or negative. Is this clear? That is the phase margin. Is there any doubt in this?
No, sir.
If you are having any doubts, you can ask me. I'll share this notes also. So you can check that example, how to draw the Bode plot and see these things also. So now theoretically also you can find them. So let me go to that example. Okay. So by the way, when these both are positive, we say that system is stable. When they both are negative, we say system is unstable. Okay.
Sir,
Yes.
the phase margin here it is. Are we calculating some kind of error that it is supposed to be the graph is supposed to be here at 180,
Yes.
but
Yes.
it has gone through? Is that
Yes. 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 Correct.
Okay, sir.
Okay, how much deviation came? So while doing the design problems, what we do? In root locus, generally what we do, if system is unstable, we try to move the root locus by adding poles and zeros to the left side or right side, correct?
Yes, sir.
Here also what we do to make it stable, what we do, so I'll move this,
Encirclement.
I'll move this one like this, correct?
Oh,
Or I'll
yes, sir.
move this one
The
like this.
shifting.
Yes, yes. By shifting the border plots, you can conclude it.
Mm.
Okay, so that is how we handle the stability, or we handle the design problems of the these things. Okay, yeah.
And one from Nyquist, sir, if possible.
Yes, yes, tell me. So Nyquist also it is similar thing. So we define the gain margin and phase margin. Okay, we define the gain margin and phase margin. So based upon the plots, and then we decide the stability over there. But mostly we take these gain margin and phase margin mostly we depends upon the Bode plotter. Let me show you this example. I think I have that example also with the direct calculations. Yeah, for this case. This case, first we have to calculate this gain crossover frequency. Gain crossover frequency is nothing but what? And magnitude is 0 dB. Am I correct? Yes or no?
Yes, sir. Yes, sir.
0 dB is nothing but what? Log 0 is nothing but what? Log 0 is nothing but 1.
Yes, sir. The value.
That's why we have 1 here. Okay, so then we could calculate omega GC is 1. Okay, and omega GC is equal to, no, this is design problem, but this is how we calculate.
So that's the
Yes.
question, sir. So such design problem will be there.
Sorry?
Such design
No,
problem
no.
will be
In
there.
quiz 2, there are no design problems.
Yeah, that's the problem because
Yes,
it's a
yes.
long one.
No. You should understand the basic definition of gain crossover frequency, gain phase margin, phase crossover frequency, and gain margin. Okay, design problems are not there.
Okay.
Okay, I think this is also similar problem. Yeah, this is how you do the gain crossover frequency. So you first find the gain margin. So gain margin is the one for the, sorry, at phase crossover frequency. What is phase crossover frequency? You equate this to 1, solve for omega is equal to omega GC. Okay, similarly, you equate this one to minus 180, solve for omega PC. So that omega PC you substitute in the phase angle. This is your phase angle. Here, you'll get the 5 degree, here you'll get 2 degree. I think this is direct theoretical example. Okay, I'll share this one right after this session. I can go through this. Okay. So you better solve these two examples with respect to the border plot. You'll understand much better.
Sir, I have sent a question in your mail regarding gain margin. Can you see?
Okay. Okay, I'll check it because now the time is already over. Okay, I'll check it and reply you by night. Okay.
Okay, sir. Okay.
Yeah, sure. Okay, thanks a lot. Still, if you are having any doubt, you can mail me. I'll try to reply before night itself.
So
Yes.
right now in
Yes.
session, if possible, can you do one of that Nyquist stability criteria? Encirclement.
Nyquist stability criteria. Just give me a minute. I'll check once. I think I have an example or not. Just give me a minute. Hello, can you hear me?
Yes,
Yes.
sir.
Okay, so this is how we proceed. Okay, this is how we proceed. Let us take this example. So this example, okay. So we have to draw the Nyquist plot, okay, for the unity feedback system, okay. So this is the example we are considering. So first substitute S is equal to j omega, clear? Then find the magnitude. Find the magnitude. So hope this is clear how to find the magnitude. Okay. What is the magnitude? A plus JB is root over A square plus B square. Okay, that is how you'll do. Then find the phase. You can also find this. Correct? You can also find the phase. Am I correct?
Yes, sir.
Okay, then Nyquist plot. Basically, it looks like this model plot. Okay, so the model plot will have different segments A, B, B, C, C, D, and D, A.